Welcome back to the Mr. G Computer Science channel. Don't forget to hit the subscribe button and give us a thumbs up for the video. So let's have a look at the exam question. The topic for this video is Little Man Computer Programming, and this is number 3 in the series. If you haven't already watched Programming 1 and 2, please feel free to do so as each video progressively builds on the skill sets. So let's check out the exam question. Write an algorithm in LMC code to simulate a countdown timer. A positive integer will be input to start the countdown. An additional integer input is required to act as the step mode for the decrement within the countdown timer. So just to give an example, if I put a 12 in as the larger number or the dividend, and I put the 4 in as a divisor, you can see from the output we would start with 12, it would decrement by 4 to give us 8, decrement by 4 to give us 4, decrement by 4 to give us 0, which is the terminating condition of the program. So now let's have a look at the code and see how we can get this thing to work. So here we have the Peter Higginson website, which is an LMC simulator. Great website. Check out the link below in the comments. Thoroughly recommend it. So I'm going to paste our code in that I've previously wrote for this, and I am going to hit the submit button, which transfers that code into our RAM locations. So let's just remind ourselves what that process involves. It will include line numbers for each of the instructions. It will replace the variable names. In this case, I'm using a variable called larger and a variable called divisor. It will replace those with memory locations as to where it will store that data. So you can see in this case, it's reserving memory location 09 and memory location 10. So this is this RAM location here and this RAM location here for the data to be entered during the execution of the program. The labels used in the jump or the branching within the code will also be replaced. So larger has been replaced with the location 09. So the branch labels have also been replaced. So the branch if positive loop has been replaced with branch if positive 05. So you can see that the branch BRP's loop will jump to this statement here. Exactly the same in the assembled version. So if you look at the branch if positive to 05, it's jumping back to the code to output exactly as it is in the code in the left hand column. So when we run the program, we have to hit the submit button again. If we run the program, speed it up, put the larger number in, we're going to use 12, and if we then put a 4 in, we can see we have a successful execution of the program. We have the 12, we have the 8, the 4 and the 0, and the program has halted. So that's a successful execution. So to help us understand the actual execution of the code, we have an input command which reads into the accumulator. We are storing that value in the larger number, so this is the dividend. We are then inputting the divisor number. So we're going to use the example 12 and 4. So 12 would have been stored in the larger variable. We then input the divisor, which will be 4. And we're loading the original number, the 12 again. We're outputting the contents of that load. Remember, load will load the data stored in location larger, which is 12, into the accumulator. The out command will output the contents of the accumulator to the output stack. We are then subtracting the divisor, which is 4. So 12 would now become 8. We are using a conditional branch statement. So if the contents of the accumulator are positive or 0, it will jump back to the loop statement and execute the output again. So the 12 would be subtracted to become 8. The branch of positive is true, therefore it jumps back. It prints out the 8. It subtracts another 4 to give us 4. The branch of positive is still true. It outputs the 4. It subtracts another 4. So the contents of the accumulator are now 0. Branch of positive is still true. It branches back to the output command, prints out the 0, subtracts another 4. So the contents of the accumulator are now -4. The branch of positive is now false. It halts the program. So let's just see that in action again. 12 is our dividend, 4 is our divisor, and we see a successful execution of the program. Hope you enjoyed the video. Don't forget to hit the thumbs up and subscribe to the channel.